Okay, now I'm calling this the third video on our bridge timeline. The second video was very short, so we're just going to quickly recap both of those. So I have my timeline here. Now my timeline actually goes in chronological order of bridges that of note. So we have bridges of different types. So we have trusses, we have suspension bridges, and that might be a bit confusing compared to the Copeland book, which is really just focusing on the 4 different kinds of bridges. So right at the beginning I made a separate video, we could call that video 0, which is an introduction to bridges, where I talk about the 4 or 5 main types of bridges. And if we go back now, we can have a look and see that the kinds of bridges, if we just do a quick scan. Okay, we're going to have to slide back and forth. Okay, they've got beam bridges as the first kind of bridge. And everything we've done in the first video, the videos so far has been on beam bridges, plus a few things that I've put in for chronological reasons. Then we want to focus on arches. Now, we've definitely talked about a couple of arches, but we're going to come back to them in a second. And then we have suspension bridges. We have opening bridges. Now, someone looked up, what was the proper word for opening bridges? Or so a variety of different kinds of bridges. Drawbridge or bascule bridge is probably the one that we're referring to when we think about things like London's Tower Bridge. Usually, or the split bridge in Manly, I think is bascule bridge. That it's usually to allow water traffic to pass. Okay, but so the next one. Okay, so trusses are going to be in there somewhere. I'm not sure where we're going to get to trusses at some point, and there'll be and also cable-stayed bridges at some point. Okay, so we're going to go follow the Copeland book for the moment. And we're going to read about masonry stone arch bridges. Now, we've talked about how we've had bridges for a long time. So the Greeks had stone bridges, but the Romans are the ones who really utilized those. Now, when we go to an example of the Romans really making the most of that, if we go to Pont-du-Gard, which is in southern France, boom, near Marseille, this is a bridge that's still you could still walk across, and it's an aqueduct. So we have viaducts and aqueducts. Does anyone know what viaduct means? No, viaduct means just it's a bridge for carrying cars or traffic or movement. Yeah. Whereas an aqueduct is a bridge for carrying water. So Roman cities were heavily populated. They needed to worry about providing clean water, so they did that through. They did use some pipework, but mostly they use these things, aqueducts, which are bridges, which are just makeshift canals that allow water to reach cities. So this is an aqueduct. And when we say that the Romans perfected this, is that the Romans were able to produce multi-story bridges in order to bridge the height, because this is particularly important for aqueducts, because the idea here is that it's not about just crossing the river safely so that the horse doesn't drown in the river, or we don't lose goods in the river. It's that the height is really important, because water won't go back uphill. So that's why the aqueducts needed to be a very specific height. So they've used arches upon arches. Okay, so once we've talked about that, we're going to quickly go back to okay, so we did look up the Ponte Rotto previously. It has since been rebuilt. The Ponte Augusto we looked at in Rimini in the first video. The biggest one is the 4-span viaduct in Narni. I think we looked that one up as well. I'll just pause. Okay, so the Narni viaduct there, the Ponte Augusto. It's a different one. So the bridges Roman, so that was 4 spans. After the fall of the Roman Empire, there was a technological dark age. Now, this is important because the technology for concrete also disappeared. So concrete they used cement from volcanic composite that acted as their cement. But the thing is that the Roman Empire concentrated a lot of wealth and population in big centers, particularly Rome. After the Roman Empire fell, we're going to use that terminology. After the Roman Empire fell, a lot of people left Rome. It went from being millions of people to hundreds of thousands of people. So all of those extra people, they spread out all over the rest of Europe. And suddenly we didn't have that concentration, the population density. So people didn't need to live in multi-story buildings anymore. They didn't need a 3-story house when they would just go and live on the farm and there's plenty of land. So when you don't need that land anymore, it's like, yeah, look, no one needs that concrete anymore. It's too expensive. So for thousands of years, concrete was just forgotten. It disappeared as a technology. Eventually, Portland cement came about in, I think, the 1400s. So 15th century, I think. But we did talk about how we started to see a return to stone bridges in what we call the Renaissance. The most significant one here is the Rialto. So if you ever go to Venice, you will by definition end up going past the Rialto. It's like on the main canal. It's a pretty significant bridge. Like many people, I have been to Venice with my wife, and we did see the Rialto. I don't think we walked across it. Anyway, okay, so there were other bridges that came after that. So there's the Pont de la Concorde, which is still standing. I think the Pont Neuf is older than that, which we talked about yesterday. Okay, so then we get to Brunel. We mentioned Brunel last time. That Brunel is very famous. He has... I'll just pause. So if you've ever seen... There's a very good series called 7 Wonders of the Industrial World. One of the episodes is on the first big steamship that was designed for making transatlantic crossings. So it was designed and built by Brunel. So there's an episode. You can watch it online for free. So Brunel was also a bridge builder. So he was like a very famous engineer at the time. I'm sorry, I'm trying to go back to that. Okay. So he built the brick arch in Maidenhead to carry the Great Western Railway. So he also built railways. So a lot of people thought the bridge was going to collapse because it was just the design was such a big increase on previous ones. There's a bit of fluff there about how he left the wooden supports in there to make people think that he needed them, and then when they were destroyed in the storm, people thought that the bridge was going to fall. Okay, so that the bridge still stands and still carries far heavier loads. Okay, so this is the bridge. It's where it's located. So we go back. We've got a picture here of the Richmond Bridge in Tasmania. The oldest bridge in Australia is Sandstone Arch Bridge. Okay, so then we're going to cast iron bridges. So there were some cast iron bridges in about 1500 BC. No. I'm going to take that back. Sorry about that. I'm not going to edit this out, but no. So the Iron Age was 1500 BC. That makes way more sense. I was a bit confused there. Okay. So yeah, the Iron Age is an important, significant time in sort of Roman and also ancient Chinese history. Okay, so the Iron Bridge at Coalbrookdale is important. We're going to show a picture of that, and I have a picture of the Iron Bridge up there. So that's the oldest iron bridge. And then we'll go back to what I have to say about it here. Okay, so yeah, so 1779. It crosses the Severn as well at Shropshire, which that's South Wales. I think when we talked about the other bridge, I said it was near Bristol, which is true, but I think it was actually in South Wales. Old South Wales. Okay. Another one was built the same river, the Bildwas, in 1796, and it used half as much iron as the Iron Bridge at Coalbrookdale. Okay, steel bridges. The first noteworthy one is the St. Louis Bridge, which crosses the Mississippi River. Okay. Whoops. Sorry if I'm. So that's also called the Eads Bridge, which is named after the designer. The Eads Bridge, and that's the first one made out of steel. So the steel was developed by this guy called Henry Bessemer. He had a converter in 1856. And what that did is that really developed, made coal readily available. Sorry, they made steel readily available. Okay, so we've got the Hell's Gate Bridge happening next in 1917. And then we're going to talk about bowstring girders, which I think we've talked about before. The most famous bridge, Australian bridge, is the Sydney Harbour Bridge, which we've talked about before, but we've got Sydney Harbour Bridge again here. So it was designed by John Bradfield. Okay, so it links North Sydney to the Sydney CBD. It's 503 metres, which makes it longer than the Hell's Gate Bridge. I think that there was a bridge in Pennsylvania that was built to be just slightly longer. Not Pennsylvania, it was in Philadelphia. Yes, Pennsylvania, not in Philadelphia. I think it was in Pittsburgh. It carries 8 lanes, 2 railways, and 2 footpaths. Okay, so it was when the reason it was significant was it was not quite the longest single span bridge, but it was very close. It was close to being the longest single span bridge. Oh yeah, the Bayonne Bridge in New York, which was deliberately built 2 feet or 600 mil longer, but it only carries traffic lanes. It doesn't carry trains. Okay, so the student question is, how did these two halves stay together before the bridge was joined? That's a good question. So what we had is big cables that suspended it back to its abutments, and eventually, when they were joined, they were brought together. Okay, so the Department of Education provides a whole bunch of resources on the Harbour Bridge. So they talk about the impact. So I mean, it's really important to as a cultural city. I think I've talked about this already. That for Sydney's growth in joining the two halves of the city is very important. Also, the timing is very important. The fact that it was built from 23 to 32 means that it was really built during at the peak of the Depression. So and so is the rebuilding after a burst of infrastructure in the 20s, and then but it was continued to be built as it went to the Depression, which is an important economic stimulus. So the bridge design was originally going to be a suspension bridge. Now, my understanding is the reason why they couldn't build a suspension bridge is because it would be too long, and that because it needed to work with the train line, that there's a very steep curve as it's built. So in order to avoid that, they went and decided to go for the single arch. So there's various different things about, so for instance, the factor of safety that when it was being built and its design. The supports are important. Supports and also the towers are important. So that when we talk about materials, if we go to say engineering materials, that the tables, it doesn't have that here actually. The tables are made from sandstone that I think is shipped from like Maroubra, maybe, I don't know, somewhere in the south coast, in sort of like between Ulladulla and Batemans Bay. And those towers, they're just there purely for decorative purposes. They figured if they're going to spend this much money on the thing, they want it to look good. So the towers are there purely for aesthetics, which is interesting because you could have had 2 bridges if you didn't care about the aesthetics. Okay, so materials that were used. Workplace safety is important. So people did die in the construction. No one died from falling, though, and I think that there was a guy who did fall. So this guy, Victor Kelly, fell, but he survived the 52-meter fall. Now, at some point, I did look at so what they call is the P50 of falling, and what P50 means is that if you fall from that height, you have a 50-50 chance of surviving. And I think that the P50, the thing you have 50-50 chance of surviving, is really pretty low. I think it's something like 2 meters. So it's the idea that if you fall from the top of, from a roof, that you have a 50-50 chance of dying. I could be wrong. I don't quote me on this. I will post something in writing on the group. But there's also the point that after a certain height, it stops mattering how high you fall. So if you fall from the Golden Gate Bridge, it's so high up that you will reach, or you come very close to reaching what they call terminal velocity, which is a certain size on Earth with air. Eventually, you'll start falling as fast as the wind resistance can push you back. So you stop accelerating.